a badly crushed human cranium unearthed decades ago from the banks of the Han River in central China, is transforming how scientists think about our own origins. The fossil, known as Yunxian 2, was long considered an obscure and poorly preserved member of the species Homo erectus. New digital reconstruction and detailed phylogenetic analysis now show that this 1 million-year-old skull sits close to the split between our own lineage and the enigmatic Denisovans. In doing so, it pushes the roots of Homo sapiens far deeper into time than most researchers had imagined, and offers a long-awaited way to resolve what paleoanthropologists have called the muddle in the middle. The Yunxian site in Hubei province produced 3 crania over 3 decades of excavations. The second skull, Yunxian 2, discovered in 1990, was partially crushed and twisted by the weight of sediments and the slow movement of the ground. For years, its deformed shape made it impossible to know exactly what kind of human it represented. Only with the advent of high-resolution computed tomography and sophisticated digital methods has a clear picture emerged. As the scientific team explains, we restored and reconstructed the distorted Yunxian 2 cranium using recently introduced technology. The results showed that this cranium displays mosaic, primitive and derived features. The researchers began by scanning the fossil at high resolution, segmenting bone from the encasing rock and digitally repositioning each displaced fragment. They also incorporated anatomical data from the first Yunxian skull to fill gaps where pieces were missing. Unlike earlier attempts that relied mainly on landmark mirroring, the new approach used full 3-dimensional modeling to undo fragmentation and displacement rather than plastic deformation, giving a much more reliable reconstruction. Once digitally restored, Yunxian 2 proved to be large and long, with a broad and flat brain case in lateral view and a cranial capacity of about 1,143 cubic centimeters, roughly comparable to the African Kabwe skull, the European Petrolona fossil, and China's Dali and Jinyushan chronia. Its face is high and projects forward. The nasal bones jut strongly, and the cheekbones are broad but flat. It retains primitive traits such as a thick brow ridge and long, low vault, yet lacks the strongly angled occipital bone of classic Homo erectus and the distinctive occipital bun of Neanderthals. As the study put it, the cranium is clearly plesiomorphic in overall form. However, it lacks both the strongly angulated occipital, with a prominent transverse torus found in Homo erectus, as well as the protruding occipital region typical of Neanderthals. To place the skull within the human family tree, the team applied geometric morphometrics to 533 anatomical landmarks across 179 fossil and modern Homo specimens, mapping them in what they call a multivariate morphospace. Yunxian 2 clustered with other Middle Pleistocene Chinese fossils, such as Dali and Jinyushan, and with the Harbin cranium dubbed Dragon Man. These fossils all fall into what the study classified as the Homo longiclade, a monophyletic Asian lineage that also includes the Denisovans. Our phylogenetic analysis shows that these Homo samples belong to the monophyletic Homo longiclade, the paper reports, adding that Yunxian has the greatest age within the Homo longiclade. The Homo longiclade, according to the study, is the sister group to the sapiens clade. This means that the ancestors of Homo sapiens shared a more recent common ancestor with these Asian humans and with the Denisovans than with the Neanderthals. The analysis used both parsimony and Bayesian tip dating to estimate when the major branches split. Strikingly, the results indicate that the origin of the Homo longiclade can be inferred to be about 1.2 million years ago, slightly older than the Yunxian fossils. The origin of the sapiens clade is estimated to be about 1.02 million years ago. The divergence between the Homo longiclade and the sapiens clade is at about 1.32 million years ago. The Neanderthal clade diverged from the Longi and sapiens clades at about 1.38 million years ago. Those numbers push the birth of our lineage hundreds of thousands of years deeper into the past than the prevailing picture built from genetics and the African fossil record. For decades, Most models have assumed that Homo sapiens arose around 300,000 years ago in Africa, after diverging from a Neanderthal Denisovan ancestor perhaps 600,000 to 500,000 years ago. The new reconstruction says otherwise. As the scientists write, both the Homo sapiens and Homo longi clades have deep roots extending beyond the Middle Pleistocene and probably experienced rapid early diversification. Chris Stringer of London's Natural History Museum, a co-author of the study and once a steadfast out-of-Africa promoter, emphasized the revolutionary implication. This changes a lot of thinking because it suggests that by 1 million years ago, our ancestors had already split into distinct groups, pointing to a much earlier and more complex human evolutionary split than previously believed. Archaeologist Shijun Ni, the lead Chinese researcher, echoed that sentiment. Based on our new discovery, we challenge the old timelines of human evolution. Thus, Yunxian too might finally resolve the notorious muddle in the middle, the confounding array of fossils between about 1 million and 300,000 years ago that seem to defy clear classification. If Homo sapiens, Homo longi, and Neanderthals had all already diverged by around 1 million years ago, then many of the strange transitional skulls from Eurasia can be seen as early offshoots or subgroups of these three main lineages, rather than mysterious archaic Homo sapiens. As Stringer put it, our analysis suggests that all large-brained humans from the last 800,000 years or so can probably be put into one of 5 groups. What's revolutionary about our analysis is that it suggests all these 5 lineages trace their ancestry back more than 1 million years. The reclassification also reframes Asia's role in our origins. For a long time, Africa was seen as the sole cradle of modern humans, with Homo erectus making an early exit into Eurasia, but evolution thereafter centered in Africa. The Yunxian study complicates that picture. Many scientists now argue that early members of the sapiens clade may have lived in Asia as well. The popular write-up notes that the fossil raises the possibility that our common ancestor, and potentially the first Homo sapiens, lived in Western Asia rather than Africa. Although Stringer cautions that more fossils and genetic data are needed before rewriting the out-of-Africa paradigm, he acknowledges the discovery more or less doubles the time of origin of Homo sapiens. The mosaic anatomy of Yunxian 2 helps explain why this skull is so pivotal. It retains deep ancestral traits shared with early Homo erectus, yet shows derived features aligning with both Homo longi and Homo sapiens. In other words, it looks transitional at exactly the point where the Homo longi and sapiens clades were splitting. As the paper puts it, Yunxian may preserve transitional features close to the origins of the two clades. Its cranial vault is long and low, but not as sharply angled as erectus. Its face projects but lacks the mid-facial pull of Neanderthals. Its brain size is larger than any Homo of that age, yet smaller than typical Neanderthals or modern humans. Such anatomy suggests a population on the cusp of the great radiation of big-brained humans. The implications ripple far beyond taxonomy. If our lineage really began differentiating more than 1 million years ago, it means that modern humans, Denisovans and Neanderthals coexisted and probably interacted for nearly 1 million years, not just the few 100,000 previously thought. The scientists told reporters, "Human evolution is like a tree. This tree included several branches, and there were 3 major branches that are closely related, and they may have some interbreeding to each other, and they coexisted for almost 1 million years, so this is an unbelievable result." Such deep time overlap also affects how we interpret genetic evidence. Many molecular studies have dated the split between our lineage and Neanderthals to 500,000 to 700,000 years ago, but the study argues those estimates may be too shallow. They note that recent evolutionary genetic studies have suggested a much deeper ancestry and population divergence in Homo sapiens, and that their own Bayesian tip dating revealed that the diversification of early humans and the origin of Homo sapiens have much greater time depths. One reason is that genetic coalescence times can underestimate real population separations if there was later interbreeding. The discovery of Denisovan DNA fragments in living Asians and Oceanians already hinted at ghost populations mixing for hundreds of thousands of years. A million-year-old sapiens clade could explain such tangled signals. Still, the Yunxian results are not without critics. Some experts urge caution. Cambridge geneticist Aylwin Scally, for example, told the BBC that one has to be particularly tentative about the timing estimates because those are very difficult to do, regardless of what evidence you're looking at, be that genetic or fossil evidence. Others, such as Smithsonian paleoanthropologist Ryan McRae, think the skull's anatomy fits well with Homo longi and the Denisovans, but question whether the data can truly resolve such deep divergence times. This study says that Denisovans, Homo longi, and Homo sapiens are more closely related to the exclusion of Neanderthals, McRae explained. But he warned that the study may have tried to do too much at once with limited data. Even so, the study represents one of the most sophisticated efforts yet to rebuild a badly crushed fossil and integrate it into a quantitative evolutionary framework. By combining detailed digital reconstruction, geometric morphometrics, and Bayesian phylogenetic modeling, the study has produced what has been called one of the most important windows yet into the evolutionary processes that shaped our genus around 1 million years ago. The story of Yunxian man also illustrates how new technology is reshaping paleoanthropology. When Chinese workers found the first skull in 1989 and the second in 1990, researchers could only make plaster models and rough measurements. Now, with digital segmentation, fragment realignment and three-dimensional printing, fossils once too damaged to study can be virtually restored to life. The Chinese team tested it again and again to test all the models, use all the methods, before trusting the extraordinary implications. Looking forward, the team is eager to examine the third Yunxian skull, discovered in 2022, but not yet fully prepared. Researchers said that once this specimen is reconstructed, it will enable the team to test the accuracy of the reconstruction and its placement within the human family tree. If it confirms Yunxian 2's position, the case for a million-year-old sapiens clade will grow stronger. For now, the study stops short of renaming the fossil as Homo sapiens. Instead, they argue it represents an early member of the Asian Homo longi clade, which includes the Denisovans, and is the main part of the sister group to the Homo sapiens clade. In other words, Yunxian 2 is in the Homo longi clade, but so close to the branching point that it captures the moment when the ancestors of modern humans were peeling away. The study does not claim Asia was the birthplace of our species, but it shows that by 1 million years ago, humans in Eurasia were already differentiating into lineages that would later produce modern humans, which implies that the first humans, leading to modern humans, evolved somewhere in Eurasia. That insight forces a rewrite of the classic textbook story. The prevailing model long pictured a single, relatively late speciation of Homo sapiens in Africa about 300,000 years ago, followed by an exodus that replaced archaic humans elsewhere. The Yunxian study instead envisions a much older and more complex scenario. By 1 million years ago, at least 3 major clades, Homo longi, the Neanderthals and early Homo sapiens, were already distinct. They evolved in parallel across Africa and Eurasia, sometimes isolated, sometimes mixing, for nearly 1 million years before the final success of our branch. If that picture holds, it resolves long-standing puzzles. Fossils such as Dali in China, Jebel Irhoud in Morocco, or Petrolona in Greece have always looked too modern to be Homo erectus, yet too archaic to be sapiens. Now they may represent early members or close cousins of these million-year-old clades. Likewise, the messy genetic signals of ancient introgression, Denisovan and Neanderthal DNA in all non-Africans, and even hints of older, super-archaic ghost lineages, make sense in a world where these groups diverged early and kept interacting. The Yunxian skull's quiet riverbank burial 1 million years ago thus echoes loudly today. As Stringer reflected, if the Yunxian 2 skull sits close to the origins of both the Homo longi and Homo sapiens lineages, it may represent one of the most important windows yet into the evolutionary processes that shaped our genus. In challenging long-held timelines and helping to untangle the muddle in the middle, it reminds us that human evolution has never been a straight line, but a deep, branching story still being uncovered bone by bone. Thank you for watching and exploring our human history together.